Hello everyone. In this video I'll go over a short lesson of notes on classification of matter and an accompanying assignment that goes with it. Okay, so if you log into the NetSchool page, scroll down, we'll go to Unit 2, and here is the link to the video in case you need to bring it back up later on. Here's the link to the notes. Here's the link to the assignment. You may or may not have all of the pages on this assignment, but the ones that you're doing would be in there. So that's what we're going to look at today. Alright, so let's take a look at those notes. If you click on that, it'll bring up this page. Classification of matter. So matter, you guys should already know, is anything in the universe that has mass and takes up space. But what isn't matter? We may have said this before, and I'll give you a hint. You're looking at it right now. Anybody? Hopefully at this point someone has answered. Energy. Energy is not matter. So light, electricity, things of that nature are not considered matter. Alright? As you probably know from a lab we did in class already, there are different types of matter. We looked at molecules and things already, so we know there's different types of matter. Matter is broken down into two major groups and then four subgroups. Okay? Matter is broken down into both pure substances and mixtures. Okay? Pure substances is what we've talked about already. You guys have already written down some definitions from this. When we did this lab, you wrote down the definitions for atom, chemical compound, chemical element, and an ion. All of these are pure substances. They're considered to be pure substances because they cannot be broken apart physically. They can only be separated chemically. Okay? So, pure substances, they are only one thing. They have to be separated chemically. Compounds are two or more elements chemically bonded, like table salt is a good example of a compound. Okay? Molecules of a compound generally look like multiple atoms mashed together. They're chemically bonded. Okay? So there's an example that's a big rock or a mineral that is a compound. Okay? If you chemically separate a compound by breaking apart the atoms, then you have atoms of an element. Elements cannot be separated chemically. Atoms can only be broken through nuclear means, which we'll talk about way later in the class. So elements only have one type of atom present. For example, gold is an element. You know that because it's on the periodic table. So atoms of an element are single atoms. Okay, look like this. Alright, so pure substances are two groups: compounds, elements. Compounds are multiple atoms that bond to form molecules of a compound, and then atoms form an element, just one type of atom. Mixtures can be separated physically because they are physically mixed together, so you can separate them physically. These usually have many ingredients, but they can be as small as having 2 or 3 ingredients. Okay? A heterogeneous mixture means that it is different throughout. The root word hetero means different, so it is different throughout the mixture. Homogeneous means the same throughout. A homogeneous mixture looks the entire way through the exact same. These are usually called solutions, so like salt in water, sugar in water, soda, things of that nature, milk, these are called solutions. Okay, so all these things are called solutions. If you look at a mixture at the atomic level, you'll see there are atoms in there, molecules, compound molecules, all these things are mixed together. Just like in soda, there's a bunch of different ingredients. There's not just 2 or 3. But they're all mixed together in a uniform manner, so it is completely mixed down to the molecular level. It's the same throughout. That's a homogeneous mixture. A heterogeneous mixture is different throughout. Okay? So far you probably haven't written anything down yet, but here is information for you guys to write down. Now, you don't have to write down all of this because you already should have the definition from an element, you should already have the definition for an atom, and you should already have the definition for a compound in your notebook. Okay? You definitely want to write down the definition for a mixture though. Okay? So what I'm going to do is I will go to the top and make sure that you guys have everything that you want to write down. If whoever's playing the video could pause it at this point for a minute or two for everybody to write down the element or compound, that would be helpful. I'll give you guys a couple seconds to do that. Now I'll move it down to a compound and let you do that one. You definitely want to make sure you write down chemical formula. Lastly, make sure this, you want all of this because we haven't talked about mixture yet, so make sure you write all of mixture in your notebook. I'll give you a couple seconds for that. Okay, so as I was saying, mixtures are formed when elements or compounds are mixed together. They can be separated by physical means like filtering, distillation, etc. Remember, homogeneous means it's the same throughout, heterogeneous means it's different throughout. So, examples of homogeneous mixtures are air, tap water, soda, jewelry, metal alloys, which are metals mixed together but not chemically bonded together. A heterogeneous mixture looks different throughout. All the different stuff can be seen, like soup, salad, concrete, salad dressing, sand, dirt, all those things are examples of heterogeneous mixtures. So those are the two types of mixtures. Like I said, we've already gone through elements and compounds a little bit. Remember, atoms the smallest it can get. We once thought they were uncuttable. An element is only made of one kind of atom. Compounds are two or more elements that chemically are bonded together. All right, and molecules are the smallest part of a compound. Okay, so the assignment that you got today should look something like this. It says, is it an element, a compound, or a mixture? It's got a little bit of notes here at the top to help you out, okay, just in case you don't have that written down in your notebook. So, if you look at the table below, what you're going to do is, in the first column, you need to tell me if it's an element, compound, or mixture. And you can just write E, C, or M depending on what it is. So, for example, argon is on the periodic table. If something is on the periodic table, you guys should know by now that it is an element. So put element in that space right there. Okay? Ethyl alcohol is C2H5OH. Obviously, there's multiple atoms bonded together there, so that guy is going to be a compound. Alright? I will give you one additional hint. Number 9, baking soda. Baking soda is NaHCO3, if that helps out a little bit. In the second column, you need to tell me if it's homogeneous or heterogeneous. You only need to tell me this if it's a mixture, because compounds and elements are always homogeneous because they are only made out of one atom or one molecule. Mixtures can be either or. So you can write hetero or homo in the space if it's a mixture. If it's an element or compound, you don't need to write it down. So element, compound, and mixture on the left, homogeneous or heterogeneous if it is a mixture on the right side. On the back of this assignment sheet, looks like this. You just have some general questions over elements, compounds, and mixtures. These should be pretty simple and shouldn't take you very much time. Identify each mixture as either homogeneous or heterogeneous. I wanted to point this one out because this throws people sometimes depending on what the mixture is. So I like to think of what I call the hand rule. Okay? Think of it like this. If you take 2 scoops of this mixture or this substance, you're not sure what it is, if you take 2 scoops, are they going to be exactly the same? That'll tell you if the mixture is homogeneous or heterogeneous. For example, let's look at hand lotion. If it's just regular old hand lotion, not ones with like little pearls or little things in it, if it's just regular old hand lotion, if I take 1 squirt of hand lotion and a second squirt of hand lotion, they should come out exactly the same. The consistency should be the same. So a hand lotion, for example, is going to be homogeneous. Okay? Whereas with dirt, if I go outside right now and stuck my hands in the dirt in 2 different places and pulled up 2 handfuls of dirt, would those handfuls of dirt be exactly the same? They shouldn't be. They would be slight differences. They may have the same stuff in them, but they wouldn't be exactly the same. There might be rocks in this one. There might be some bugs in this one. So those dirt would be considered heterogeneous. Okay? Hopefully that's enough information for you guys to be finishing this assignment. So like I said, make sure you've got the notes you need from here. If you need to get them again, you can go back to NetSchool. They're right here, classification of matter. The assignment should be already handed to you, but if you need it, it's here, elements, compounds, and mixtures practice worksheet. If you guys have any questions, you can ask one of the nearby teachers. Hope you guys are having a great day. Talk to you later.